Algebra 1 kids, this is Dr. Callahan for week 2 Thursday. I hope you guys are having a wonderful week. Go ahead and pause the video and answer the following 3 questions on your warm-up log. Okay, let's go ahead and create the assignment for week 2 Thursday. So we're going to go over to the assignment and then go ahead and we're going to go ahead and create it. Assignment. I am excited to see you guys in person coming this Tuesday. Remember, Monday is Martin Luther King's birthday, so there is no school on Monday, but school will resume on Tuesday. So this is for week 2, Thursday, for Algebra 1, semester 2. Our topic today is going to be transformation of exponential functions. Your instruction today is as follows. Make sure you guys go ahead and watch the video on the YouTube channel. Do the activities. It should be equivalent to 45 minutes of lessons and instructions. There's actually just one link for you guys, and that's a YouTube channel. It's this tiny URL right here, and hard copies are available outside of my classroom in B1. Monday through Friday, 7:45 till 3 p.m. outside of B1. And just keep in mind that make sure you're doing this and doing the instructions and checking in with me during the assigned first period, which is going to be from 8:30 till 9:15. You do get the 10 points if you upload your assignment. And as always, your assignment is due the very same day by 3:30 p.m. And we're going to go ahead and assign that. All right, let's go ahead and take a look at the guided notes for today. You really just have like 2 pages of guided notes today. And let's go ahead and paste that. So the first page is your guided notes. When it comes to transformation, you have an equation. I'm going to tell you what they actually stand for. And then the second one is a thing on Kahoot, quizzes, and Quizlet. So we're going to go ahead and save this. And I'm also going to attach it to the assignment so that in case you would like to print it out for home, you have that option. So you're not printing out all 100 pages of week 1 to week 6, and you just simply print out the ones for week 2 Thursday. All right, so let's go to Save As, Browse. Oops, not fall, Callahan. It is spring 2021, Algebra 1, week 2, Thursday. And we'll do this as a PDF, so that way, if you don't have MS PowerPoint, that's not a problem. All right, let's go back to this. Go back to Algebra 1. Here's your assignment for today. And I'm just going to go ahead and attach your guided notes. So in case you need to print it out from home, you're welcome to do that. Or you can even grab the hard copy outside on my desk on B1. And B1, there's a desk outside and you just grab it. All right. And that should be attached. Cool. Let's go ahead and get started with today's stuff, you guys. So last time I saw you guys, we went ahead and graphed the equations and determined whether it's an exponential growth or decay. We went ahead and practiced with some of the word problems that we had. And so then today, this is the breakdown of we're going to be discussing. We're going to talk about notes on exponential growth and decay using transformation. All right, so first things first. When you have this equation that's in front of you, y equals negative a parenthesis b, negative e to the x minus c plus d. Now, all of these letters represent how your exponential function is going to be moving, okay? So this is the first one. I have a little chart here to describe it. Now, the b right here, so in your case, it's a negative e. That is going to determine if it is going to go if it is going to be stretched about the y-axis. So looking at the b right here, okay, if it is going to be a big number, bigger than 1, it is going to be a skinny shape, okay, because it's called horizontal stretch. So a skinny shape in that sense might look something like this, so your graph is not as stretched. So let me go ahead and move it over. So it might look something like this, like very narrow, okay? Now, on the other hand, if this b is going to be smaller than 1, like 1/2 or 1/4, it might be a little bit fatter and a little bit more stretched out like that. Okay, then we're going to talk about the following. The A is going to be a vertical stretch, okay, about the x-axis. If the C here is a negative in front of the C, what that means is that it is going to be flipped about the x-axis. So if you, for example, have a star right here, and that's your graph, you just flip it over the x-axis and it's going to be on the bottom. And that's if there's a negative. If if the negative is with the exponent right there, like with the x, it's going to be reflected about the y-axis. So if you have a happy face here, here's the y-axis, you just flip that happy face over to the other side. The k here determines whether it's going to go up or down, okay? So if it's going to be bigger than 0, then you're going to go up. But if it's smaller than 0, you're going to go down. And then, of course, the h that's attached to the x is going to determine if it's going to go right or to the left. So if this h is going to be bigger than 0, you're going to go to the right. And if it's going to be smaller than 0, you go to the left. All right, so then on your guided notes, I want you guys to go ahead and label your equation as follows. For A, make sure you label it as a vertical compression or vertical stretch. For the K, make sure you label it as a horizontal stretch or compression. The D is going to be a horizontal transition, which means either go to the right or to the left. And then, of course, the C is going to be a vertical translation, so it's either going to go up or down. So what I want you guys to do right now is on your equation, go ahead and label it. What is this going to negative tell you? What is this B going to tell you? The negative E, the negative C, and the D. So go ahead and label it as up, down, fat or skinny, left or right, reflects X, reflective of the Y-axis. So pause the video and do that. Okay, so next what we're going to do is we're going to practice with this. We're going to do this thing called Desmos. So you're just going to type in Desmos and you should have something that looks like this. Okay, so just go to desmos.com and you'll have this graph right here. Okay, so this is going to be your calculator. Now with your guided notes, you have this example here. It says match each graph with the equation that is shown. So here you have 1 to 6 and you need to match it either to A, B, C, D, E, or F to the graph. Okay, so let's go ahead and practice with one. So looking at the first one, it says y equals 4 to the x plus 3. So then what you're going to do is going to go back over to Desmos. And you're going to do y equals 4 to the x. And the x, you want to do the little caret sign, which is by the number 6. And then push the arrow button so your cursor is down, plus 6. Just want to make sure that's correct. Oh, plus 3, just kidding. Plus 3, there we go. So here is your graph, you guys. Now looking at this graph, because this is what I just graphed here, which one of yours looks similar to this graph? If you look at it, it kind of looks like it starts at 4 and it just goes up like that, okay? So then let's go back to what we have here. Which one of these graphs starts at 4 and it goes up? And remember, your graph looks something like this, okay? And it starts at 4. Well, I know it looks similar to A, but A actually doesn't start at 4. A looks like it starts at 5. And the only one that looks like it starts at 4 is going to be E. So then this one goes here. And then what I want you guys to do is reflect on number 1 and answer the following questions. Okay, let's try another one. Let's try number 5. For number 5, it says 0.25 to the x minus 5. So I'm going to go back to my Desmos. So I'm going to change the 4 to the 0.25 like that, and then change the minus to a minus 5. Okay, so here is my graph. And what this graph, notice that how it is hitting the 2, or actually 2, 4. So it's hitting a negative 4 right there because it's counting by 2s. And it's also right here. If this is 0, this is at probably 1. So is there one that looks like it's going up on the left side? It starts at negative 4, and then it shoots up and it touches the x-axis at 1. So let's go ahead and give that a try. So it starts at 4. Oh, you know what? It looks like it's this one right here. So then this one goes to this one right there. So then what I want you guys to do is go ahead and practice with this. Type in number 2, 3, 4, and 6. Give it a try and see what happens to the slider as you guys are working on this. Okay. Okay, next what I would like you guys to do is to go ahead and take a look at the left side right here. And what I want you guys to do is go ahead and try this by inserting this into Desmos and then reflect on the questions here and write down your responses using Desmos. Okay, you should be done with 1 to 6. So if you would like to check your answers with me, I have my answers right here for 1 to 6. And this is what it should look like with your arrows. 2 points apiece. All right, you guys, that's basically all that I have for you today. As always, stay safe and healthy. And actually, you know what? I have one more thing. Just kidding. Sorry. One more thing. I have a little video that I would like you guys to watch with me. So give it a second as it is uploading. Okay. I'm going to stop right here, and just to reflect and reiterate one more thing about this, just remember when you see the x right here, x plus 3, if it's a positive 3, you're going to go 3 to the left. If it's a negative 3, you go 3 to the right. The negative 1 means that you go down. So if it's a negative 1, you go down 1 step, and if it's positive 1, you go up 1 step. The negative in front of the 2 here means that it's going to be flipped over the x-axis. So this graph here will be flipped over this way, kind of like a symmetry of your hands. And this 2 right here, because a 2 is bigger than 1, it means it's going to be a skinnier, exponential function. So it's not as stretched out, but skinnier. So then if you take a look over here, this is a graph of what it will look like. You're going to start at -1, so go down 1 right there. 3 units to the left, 1, 2, 3. It is reflected over the x-axis, so if you take a look at the blue and green line, you just flip it over like in the yellow one, and it is smaller, or it's bigger than 1, so it is going to be stretched a little bit more. So it's a little bit skinnier of a graph, a little bit more compressed. All right, you guys, as always, stay safe and healthy, and I'll see you guys next time. Take care.